right, we will touch upon the language itself, right? We talk about smart contract, blockchain, right? But how to write those smart contract, right? How to so what actually happen when we deploy those contracts, right? So until unless we don't know the language of the blockchain, we will be not able to develop on that, right? So this is where this session is all about. Given we have touched upon Ethereum in last few sessions, so we will use Ethereum based language, right? So Solidity again is a language for Ethereum or Ethereum virtual machine. So any language that can compile their high level syntax into EVM bytecodes can be language for Ethereum. But I think 95 to 96% people who use Ethereum, they use Solidity compiler to convert Solidity programs into the bytecodes, right? So Solidity is very small language. Maybe I mean it is the smallest language that I have ever seen, right? So you can within a week you can easily ramp up yourself on Solidity, right? So say Java may take 6 months, C++ take 4 months, right? Other language take few more time, right? Rust take 1 year. But I think my experience with Solidity is if you have some programming background, this language is such a small language that you can say I'm master after 7 days, and I'm not kidding. So this is a 90 minutes course I prepared previously, so we will go through that. But I don't think that we will take 90 minutes. I think we can wrap up in 70 minutes, right? So I just need your attention for 70 minutes, and I hope you will learn more about Solidity. Once we complete this session, there will be part 2 of the Solidity. In that, we will do certain hands-on, right? For that, I want you guys to remain in front of your laptop, and we will do some hands-on exercise, right? In the 120 minutes, we will take 2 or 3 programming problem statements, and we will try to code on those problem statements, right? So second session will be hands-on. But it won't be possible without this session, right? So try to understand this Solidity. Once this is done, invest your next week learning more about Solidity, right? As I told, it's a simple, small language. So a week time will be more than enough, and next week we will actually dive into the implementation. I hope I'm clear, and we can deep dive into Solidity, right? So few jargons that I will go through. Some of the jargons you are already you have already come across, right? In previous sessions. I just repeat those. I will not go into deep, but in case if you want me to repeat, open up your mic and let me know. So Ethereum virtual machine, guys, right? So this machine is the machine, right, which actually execute your smart contract. So when we say we have blockchain is a say chain of multiple nodes, right? What those nodes all about, right? So node is a bigger terminology. It has many functions. One of the important function that node has, right? It has some kind of a virtual machine to execute a transaction, right? And those transactions will be executed based upon your smart contract. Okay. So when I say this, say assume this, right? You have a network of say 5 node, 1, 2, 3, 4, 5, right? Node is a bigger term. It packages many things like RPC server, WebSocket server. It will have P2P networking communication for communication between or among nodes. But one thing that every node will have is EVM bytecode, EVM machines, right? So those who are coming from say Java background, right? They might have heard about Java virtual machines. So when you write your code in Java, it will be compiled into bytecode, and Java virtual machine basically take those bytecodes and execute your programs, right? Similarly, the bytecodes for Ethereum is different, right? And so the name Ethereum virtual machine. So all these nodes will have this virtual machine, and they are capable of running any bytecode or Ethereum bytecodes. Okay. So EVM is part of your node. Miner, we know, right? Anyone who basically mine the transaction or produce a block can be categorized into miner. As we said, miner keeps on producing block and putting it in on a chain, right? So block is coming from that. Transaction is another subcategory of a block. Every time you do a transaction on a network, it will basically return into a block, right? One block can have n number of transaction. Again, we talk about consensus algorithm last time, where we say proof POS, POW, POA, right? And there are so many consensus algorithms coming every day, right? So there is active research going on, and we are moving from, say, unhealthy consensus like POW, which requires a lot of power. We are moving towards some saneful kind of a consensus algorithm like POS, where you put your stake, and your stake basically will be your authority on processing the transaction, right? Similarly with the POA and other consensus algorithm. Account is an important construct, right? Your identity is your account. There are two type of account. One or a counter address, right? There are two type of address, say a person address or a public address, right? So each individual who is doing transaction on network through a decentralized app, right? They need to have some kind of a public address or account, right? So if a particular account has 100 ether, so that ether belongs to a particular account, right? And that account is managed by some kind of a wallet. Again, wallet is a public private key pair, right? So public address is the account address, and private key is basically used to do certain transaction on the network, right? So without this key, no one can take any money out of your account, right? So that's another important jargon. Smart contract I told, Bitcoin has a single smart contract that do transfer of money. Ethereum said people can come and execute project, right? So they have to create their own language. So this is where the virtual machine come into the picture, and they said anyone can write any kind of blockchain code or smart contract if they know how to produce bytecode for EVM, right? Over that, they also created one language called Solidity. This is what we will cover in next 60 minutes. Okay. Mining, you guys already know, nothing to repeat. Ether is the currency, is the native cryptocurrency for Ethereum, right? So Ethereum holds a value. People do trade on that, right? It's a speculative currency. Not only that, even the gas fee that we pay per transaction, that is paid in a Ethereum, right? So free Ethereum cryptocurrency. This is a very coupled terminology, but I think you will be aware about this. I think so how transaction happen, right? This is just a pictorial diagram, but this is something a repeat that you guys have already done. So here what happens is there's an externally owned account, right? It's try to send a message or invoke a contract function, right? Or sending money from one account to another account. So once that signed message goes to, say, Ethereum node is running EVM, right? So EVM understand this account has called a function in a smart contract, right? Because it is aware about the bytecode that is deployed here. So based on the message, it check whether it has been signed or not. If it has been signed, what kind of operation it is asking, right? Assume it is asking to transfer a fund. So this EVM node will check whether this account has enough money to transfer. If it has enough money to transfer, it will execute the transaction and broadcast the transaction, right? So this is what happens, and finally transaction will make it to the block, right? And we know about how block are kept into blockchain, right? So starting with Genesis block, every I think 15-second Ethereum generate a block, commit too many, I mean around 30 to 100 transaction per block, right? and then block is created periodically, right? So we have a concept of block hash, transaction hash. So these concepts we have already gone through. Okay. Again, what I am telling you guys, what is happening here is you will write your contract into Solidity. Then there is a Solidity compiler that you will use. I think in the last session also we have used a Remix ID. We try to compile it, but I have not gone in depth. We'll go when we are doing the actual coding. So we have a Solidity compiler that takes the Solidity code and convert into the bytecode that EVM needs, right? EVM cannot execute your Solidity code directly. So it's only needs bytecode. So compiler do that job of converting this Solidity code into Solidity compiler, and then it executes the bytecode, right? So bytecode once deployed and executed on the EVM. So it's just repeat of things that we have done in the previous session. It's just a refresher, right? It is not the language that we are going to learn soon. Right. The important piece is how this works, right? Again, rephrasing, each node will have a EVM as one component. EVM knows bytecode, right? Any language which can be converted to the bytecode can be used. But Solidity is the language of preference. It has, I think, 95% or 96% adoption in Ethereum community. So we will touch only the Solidity piece. So now we will go into the language itself. I hope this will be visible. I'm making the font larger. I think this should be good, right? So a Solidity file, right? It's like a JavaScript file end with .js or Java file end with .java, right? Similarly, Solidity file has its own extension that .sol. It is not a big language. It has 4 or 5 constructs, right? First is pragma. Pragma is basically a hint to the compiler which compiler version to use. It's a very dynamic language. A lot of changes happen, right? It's a lot of breaking changes happen. Most of the mature language don't have breaking changes, but it has a lot of breaking changes. So pragma helps compiler to check whether the code that is being written, right, follow a certain version or not, right? Then you have comments. So every programming language that you work on, right, they have some way to write the comments. Without comments, it's very hard to read the code, right? So this is where another construct comes. Then import. Solidity can be managed into multiple files, right? You don't want to write a smart contract into a single file. You can have your dependent contracts or utility or library into another file, and we can always import those files into our code, right? And then after the import, we will actually write either a library in the Solidity file or as interface or a contract or everything into one, right? So these are 4 or 5 layers you will see in a Solidity file, right? So how pragma look like, right? So here I'm saying my hint to the compiler is we will use the Solidity version, and currently it will use 0419, right? So ensure that my major version, my minor version is same, right? Tilde basically tells you can have a bigger patch version or a smaller patch version, right? So this is major version, this is minor version, this is that. If you are using a Solidity compiler, say 05, right, it will throw an error. If you are using compiler, say 03, it will throw an error, right? So it's very important. This line is not optional. You have to provide a pragma, which basically tells which compiler to use, right? It may happen that you have written your code into 090 or maybe 0820 or something, because I think that is the latest. And if you try to compile with 05, right, it will not work, because it's such a dynamic language. If you try to compile with the old compiler will not recognize the new syntax. Not only this, you have to stick with one version. You can provide the range of version, like this Solidity file should be 050 to 080, right? You can have those syntax, right? So that's a homework. how you can provide a range. Just do a simple Google, you will find you can provide a range of compiled version, right? Comment, there are multiple ways to comment. Most programming will follow this. Double slash is a single line comment. Forward slash asterisk ending with asterisk backward slash is basically your multi-line comments, right? Or there is a net spec also, not very used, but that's another thing. At least I have not used it. But if you want to use this, you can see what is net specification, right? Ethereum natural specification. Then I told pragma done, right? Comments will flow from contract to method everywhere, right? So this is not that it will in the same order. The next piece that you will do is you can import say another contract, right? You may have a node module where you have say ERC20 or ERC721 contract, right? You want to import it. So this is how you will import it. Or it may be possible that you have written something in your own project, right? For that, say you have written common library.sol and you want to use that common library, right? For that, you can directly import file name from the current project, right? So what we have learned is we have pragma, we have single line, multi-line comment, and then we can write multiple contract in the same file, right? Or multiple library in the same file. But this is how the overall construct will look like, right? There is an interface and abstract also we'll touch upon in later slides, right? So this is that was a high level construct. So far, any question before we move to say some other construct that it will have? Okay, so at high level, we said it can be a composition of contract, interface, library, right? Or abstract contract also, right? So, but within those construct, there are sub construct also. We have to somewhere define the state variable, right? What is a state variable? State variables are the variable that actually go to ledger, right? That every node share this ledger. So there should be some kind of a state variable, right? Then we will define some structure definition. There are multiple way to construct your own custom type. Structure or struct is one custom type. Enum can be another custom type, right? So these are another construct. Modifier, we will learn that if you want to have a method, right, that basically modify the behavior of that method, right? So if a particular method in a smart contract, I want it to run only by the owner of the contract, right? So I can create a certain modifier and annotate that method with the help of a modifier, right? And then we can have functions also, right? So some sample example is this. Here you see anyone at any variable that we define, right, in the contract outside a method or a structure, that will become part of your state variables, right? So it can be a primitive type like integer, it can be string, address, right? It can even be a custom structure that you have created, right? So in this case, your personal detail is your structure, right? And a structure is basically composition of other types, right? So state variable actually goes to your blockchain database or blockchain state that will be shared among all the nodes in the network. Modifier, as I told, is basically some kind of annotation that you put on a method to change the behavior, right? Here I ensure that this modifier ensure your sender is only the when it is personal identifier, otherwise it will not be invoked. Another thing that I missed is event, right? So there is no such thing called logging in Ethereum, right? So what happen is after you are executing a complex transaction, right? How people on the network will be aware whether your code is getting executed or not, right? So this is where you generate event when something eventful happens in your transaction processing, right? So you can you can declare your event like this with the event keyword. Other signature is similar to your method, right? So even take the event name or the type. Currently, it passed the two parameter like address and integer, right? Enum is same as enum of any language. It's an enumerated list, right? Enum of say gender is male, female, maybe now more genders. Then we have say weeks, right? There is 7 days in a week, so enumeration is same, right? And our contract will obviously will have some kind of method, right? And this method can be external. This method can be pure. This can be view only, right? So I will go through each of these keywords because it is part of other slides also, right? But in this, what we have learned is your contract will have a state variable that will go to the actual database, and it will be shared among networks, right? Each node of the network. Then it's not only the primitive type like an integer or a string or address or a boolean, right? You can always create your own complex type, right? Which will be composition of other types, right? Then we learned about modifiers in case if we don't want to hard code few things every time, right? Like this function is executed by the owner of the say owner of the contract, right? Rather than writing in the code, we can always annotate. I hear some noise. Okay, so this modifier is basically can be used as an annotation to change the behavior of the method. Then we saw that there is no concept of logging in say EVM, oh, sorry, Ethereum node, right? So how we know what is happening during transaction processing, right? So this is where these nodes are able to generate certain events, and these events can be captured by your client, right? Like a decentralization app that you will create. So you can always listen to these events, and based on certain events, you can take certain actions, right? Enum we discussed, and obviously contract will have a number of functions, right? So this is very common thing, right? Each language will have it. Some language will have it differently, but we know there is a value type. What it means is when you pass that parameter, right, or argument from one variable or one function passed to the function, the value changes hand, right? It means a is not a reference, right? I am saying it's an unsigned integer equal to 13, right? And when I say what is a is the value, right? A is not the address of 0x3. So it is stored in 0x3, but the value of a is always 13, right? So this is a value type. It means the variable itself store the actual value rather than reference, right? So what is reference type? So reference type is like this. So assume that I created an unsigned array, right, of say length 6. Here, when I say a is not the value of this array, right? A basically points to the address where this array starts, right? So this address starts at 456, and it has a length of 6, right? So and it is unsigned integer, so length 22, so 0, 1, 2, 3, 4, 5, right? So based on the size of your unsigned integer, the value will be stored. In this case 22, 33, 44, 55, 66, 77, right? And you can actually access this with the help of indexes, right? So if I say a2, so it will give me the value of 44. So what are how any known value types? The answer is yes. Some of the known value types is Boolean, right? The value it can take is either true or false. Uint, right? So it means unsigned integer, right? So anything 0 and beyond 0, right, till it can hold, right? So it has a size. So take it as a homework and check what is the size of uint in a EVM. Then we have int, basically integer. It's a signed integer. It can take both the value of negative value 0 and positive values. but you have to check what is the size, right? These also have a size limit at hardware level, so you ensure that it doesn't cross the hardware limit. Then address, I think we discussed addresses. There are two types of addresses, the address of the wallet of the person or the account, and address of the contract, right? So when you deploy your code actually sits somewhere in the EVM, right? Or not on the EVM, on the node storage, right? And EVM can access it later so that it can execute it. So again, this is a value type. It is not a reference type, right? So it's actually holds the actual value. Again, byte is another type that will be value type. It will not be reference type. Enum will be value type, right? So reference type, one example I'm showing, your array type is your say reference type. It doesn't hold the value. It basically holds the reference where the value exists. There are other also like string and other types. Those are reference type, right? So actually I have given it here. Array is a reference type. Structure is a custom user defined structures, right? Custom type. Again, we have the language has made it as a reference type. String is nothing but a sequence of character. Again, it's not a value type. When you pass it, you are passing a reference. You are not passing a value, right? Also, there is a mapping, right? So those who knows, say, who are coming from Python background, JavaScript or Java background, they have something called dictionary, hash map, right? Or hash table. Similarly, those construct can be denoted in Solidity with the help of mapping, right? So it's a key value pair in case you need to store, say, account and balances, right? So you need some kind of a mapping. So there are multiple use cases, and once you become proficient in, say, Solidity, you will use mapping a lot. Okay, so I will come to this, but I think I should take a break for questions. Any question, guys? I think I'm doing a monologue, and I don't want to do that actually. Those who don't want to open the mic, they can post their question on chat. I can wait for 30 seconds before moving on. Okay, so I take silence as no, there is no questions. No worry, guys. So now what? Just a recap, right? So first thing we came to know that there is a high-level construct. Within contract construct, we have, say, a state variable, function, events, enums, structures, right? In last, we saw some type as a value type, some type in Solidity as a reference type. Very common programming concept, right? Now move to storage, right? Where it will be stored, right? So these keywords, when you see in the code, then you will come across, okay, if I see this keyword, it means it is storing somewhere, right? What is that somewhere? We'll discuss it, right? So first is storage, right? What is a storage? This is a global memory available to all the function within the contract. This storage is a permanent storage that Ethereum store on the every node within an environment, right? So this is global, means it is visible to everyone, right? So this is the storage that is shared across nodes, right? So if you come across storage, so it means that it's a global storage and it is accessible among contracts also, right? Then memory. What is memory? This is a local memory available to every function within a contract, right? This is a short-lived memory, right? So if you see any method, right, if it does certain operations, some of those operations require certain storage to store some values, right? So if you are storing those value, right, in a memory, it means it is only lived till your function is living, right? So if you are using memory, it means it lifespan is only till the execution complete the scope, right? So so this is basically your state memory. This is basically kind of your function memory, right? So once function is out, your scope of that variable goes out also, right? Its life don't live the execution. Then there is call data also, right? So what is a call data? So when you basically say calling a function from outside, right? So you pass certain data. So those data don't go into say memory, right? That function uses. So in function you will create few variables that will go into memory, but call data is basically holds your arguments, right? So say I am transferring money, right? So what will be the argument? The argument will be from where you are transferring it, right? So from to and how many ethers, right? From to and value. So these are function arguments, and these sits in a separate storage called call data, right? Then you will question me what is memory, right? So memory is so assume within a function you are storing temporarily that value, right? And increment it via one more ether, right? So you are saying uint a equal to the value plus one, right? So you created a new variable a there, and that variable sits somewhere, right? So that will sit in memory. Okay, so memory is a storage that will be short-lived. Cold data is again immutable, but very small lifespan when the transfer take place. And this data, right? I gave you example are basically the argument you pass to the function. Then you have stack guys. Every virtual machines can be implemented as a register-based machine or a virtual machine. So EVM is a stack-based machine, right? So it handles its own memory where it keeps the intermediate values and instruction set, right? So EVM use stack for its own operations, right? Currently, it can have 1024 stacks. If you try to call a recursion, right? Those who have seen recursion kind of error, so you will soon see some kind of error, right? It goes into out of memory, right, or out of stack kind of exception. Similarly, EVM has a limit of 1024. If you try to create more function, more stacks, right, then you are gone, right? Then it will give exception. This I will give as a homework, right? Just go through this. So I think there is one more questions also, right? So I will take question also. I am sending this so that you read it at home and understand what is happening there, right? So this all is today's question, is it? Oh, sorry. So I'm seeing this question now. Wait, guys. So I will take questions before I move to another slide. Ritisha Pal is saying how to sign up, right? I think in last we discussed we have DL Unify.dltlabs.com, right? And click on early access, right? And fill up the details. And once you register, we will approve your registration. It may have happened that last time registration was not approved. I will ensure that that happens together, right? So those who are new joinee, just go to dlunify.dltlabs.com, click on early access, fill up the details, and you will have your registration in place by Monday. Okay. Second question. So I think Ritisha we answered. Ananda Sahu, I am doing under. Oh, this is a previous question. Today is what? 11th. Today is not 11th June, right? Sorry. So okay, sorry. So I was reading 11th June questions, and it's the same teams. It was showing that thing, right? Sorry for that. Actually, there is no questions, so I will move to next. So now you may have seen some types also, right? So types is basically define what kind of value it holds, right? So this is just a list down or a recap of all the types that you will see. Literals is basically your constants, right? It can be string literal, float literal, integer literals, and whatnot. Integer is a integer type, right? Anything that is discrete, right? 1, 2, 3, minus 1, 2, 3, 0, right? So those comes into integer. Boolean type is basically your true and false. Byte is your byte data. Just check the size of byte, how much one byte stores. Array we discussed, its array is basically your container that holds similar items, right? It can be array of struct, array of integer, array of boolean, or anything, right? Then I don't know why bytes came 2 times. Then string, right? So string is another type that holds textual information, right? Structure we discussed. It's a complex data type or a user-defined data type, right? It can be built from multiple other types also, right? It's a reference type. Then we have enumeration like male, female, Sunday, Monday, and all those things, right? That can be enumerated into a fixed set. Address we discuss, you have a public address and you can have a contract address. Mapping is just a hash table dictionary, right? So it's nothing, this is just a recap of all the types that we have come across. Right. Now this is magic variable, right? So some of the things or some of the keywords you will see in the code, but some things that will come out of the box, right? And you will be confused. What are these? What are these, right? So say you have a block variable, right? So block, as you know, right? If you try to link it with the actual block that a block producer or miner produce, right? So block is same, right? So block has a difficulty, correct? Block will have a some kind of a gas limit, right? And Coinbase, right? Just think of block as a magic variable providing certain attribute and value in runtime, right? Similarly, message, right? So if someone is calling from outside, right, or within a contract, I am calling another contract, right? So what is the gas? Right, transaction or TX is another variable that comes out of the box, correct? If you want to know, okay, my chain is running from say last 1 year, right? So every 15 seconds, if you are producing a block, you will be producing in millions now, right? So block dot number give you that block number, right? It can also give you block dot timestamp, correct? So at what time that block has been produced. Also now will give you current time, right? And when you pass your message from say client or internal calls, you have a message variable, right? So message will have data attribute, signature attribute, value attribute, right? Who is the sender, right? Who is the origin? So these are important variable. You don't define it. Solidity will give you out of the box, right? So anytime you want some of these attributes in your code to do certain business logic, right? These magic variables will help us, right? So automatically it will be injected in your code. You just use it and build your business logic around it, right? And it's very useful. Sometimes you need to know what is the blockchain block number, right? What is the timestamp? You need to know who has sent it, right? Right, and what is the value? What has actually been sent, right? So these are some magic variable giving you magic data that you need in your processing, right? So I have given some definition. So it's similar to what I have gone through here, right? But when you are reading yourself, just take your time and go through each of these magic variable and their attributes that we can use while writing the Solidity code. These are control structure, guys. Again, it's nothing different. Every language that you will come across will have this. Expressions is basically expression something that you can evaluate, right? Say a 2 + 2 is a expression, right? If and else basically is your control structure where you do based on certain condition you do X. If your condition fail, you do Y, right? So this is if and else construct. While as we know, it's a loop. While and for both loops are supported. So you do a certain thing in a loop till you meet a certain condition, right? For is another alternative for a loop. Those who are not using while, right, they can always use for loop. For loop basically has a syntax of initializing the variable, putting condition, right, and then incrementing the variable. Then you have break and continue, right? In case if you want to break out of the loop, or if you can use break and continue keywords, it's similar to all the languages that we have, right? And in case if you want to return from current function, right, at any point of time, if you think that you have met the condition, it's time to return either a error or success or some other information, you can use a return statement, right? So these control structure provided into these examples, nothing super great about it, right? So if do this, if else if then do this, if nothing then do this, right? It's a simple if else structure you might have come across in your life 1,000 times, right? While structure, if you see, this is how it looks. I have initialized I equal to 0, and then I am checking whether I is less than counter, right? So counter may be 5. So this loop can be run at most 5 times, right? So here I am running it, say counter equal to 5 and I equal to 0. Then I am doing certain operations, and then I am incrementing I, right? Once I hit the counter 5, it's time to say, okay, my condition has met, and then it will execute other statement if those are there, right? For loop is another loop, but with a different syntax. Many prefer for loop rather than while. Again, you define your variable here, I equal to 0, then you say I equal to less than counter, same condition there, and then you can increment it here only, right? So rather than doing multi-line, you can provide the for loop in a single line. So it's based on your whether you like a for loop or while loop, right? Or whether implementing a certain logic will be easier. You can use any of these loops. There is one more loop called do while. All right. So in previous loops, you were doing something, right? In this first, we will execute the statement and then we will check the conditions, right? So there are certain scenario where you feel that either a while or a for loop will not suffice. This is where you use do while loop, right? So it's totally depend on your business logic. Break statement, guys, in case if you want to break the loop, you use the break statement, continuous statement. Basically, if you don't want to execute this part, right? If you want to continue with the next iteration, right? So you do the continue. Say if I is greater than 5, then don't execute this line, right? So continue basically prevent you from executing rest of the line based on the conditions. Return statement, if your function, right, return something, so you can use return statement, right? So it's nothing new. If you guys know any programming language, the construct is simple. It's not even a 1 degree change in terms of control structure, right? I've just gone through so that we can complete it. So now we have just a recap again, right? So I will take a overview here, right? So high level construct, guys, we have gone through. Within high level construct, there is a contract construct, right? Within a contract, I have to define state variables, enums, events, structure, right? Functions. Then we gone through certain types, right? Like integer, bytes, enums, structures, right? Those are types, right? Some of those types are value types, some of those types are reference type. And then we saw that during runtime, we have some of magic variables, right? These magic variables provide certain information that will be very useful in your Solidity code. This is nothing new. Each time you code, you need this construct, right? Do these things in certain cycle, in certain conditions. Now we will go through the actual smart contracts, right? How to create a contract. So in this case, say I created a sample contract or a hello world contract here. I can handle the contract in a two-way with the help of new keyword and with the help of existing address, right? So what is the difference between the two, right? In case if I use the new keyword, say I implemented a contract, hello world contract, assume, and in that there is a function called hello DLTs, right? So this contract, when I say hello world, new hello world, what it will do is it will deploy the contract for you, right? It will call the constructor and deploy the contract on Ethereum node, right? So so the new keyword in Solidity deploys and create a new contract instance, right? It means it will create a new deployment, and once you deploy it, as I said, right, your contract has an address, correct? So it will return the address of the contract. So it initializes the contract instance by deploying the contract, initializing the state variable and running the constructor, right? And eventually return the address of the instance to the caller. So what has happened here is hello world, if I call within my contract, it will deploy, it will take the contract and it will deploy the contract in EVM and get the address of that contract, right? So my object.address will have the address of the contract. So this is that hello world, right? So so take say hello world is there. There are two methods, get value, right? A simple integer or a set value, right? So here I have a contract client, right? So here what I'm doing is I'm using the new keyword. So what this will do is this will deploy my this contract. Let me do this. Right, so this will deploy my hello world contract and return the object, right? And this object will have set value, right? So if I use the contract, then just give me a second, guys. So if I use say set value, right? So there is a method set value, and you pass the value onto set. Once you set the value, you can always use .get value, right? So it will give you the value. But there is another way also, right? Most of the time in your smart contract development, right? You will reuse the existing contract. You will not deploy the contract again and again, because deploying a contract is an expensive job, right? So for that, what you will do is you will use another syntax, right? In this, what I will do is I know there exists sorry, hello world. Sorry, there exists a contract hello world already there, right? So why not I pass that address of the contract and get a handle of it, right? In this previous syntax, I was deploying the contract, generating the new instance, and then getting the handle on it. In this case, I say I already have the address, right? So why create a new instance, right? So here I will not pass. Here I will not create a new instance. There is no new object, right? I just say hello world and pass the address of that contract, right? So that contract will be treated as a hello world contract, and then I can use it. So if I see this example here, what is happening is there is an address obj, right? So this is the address of the hello world contract, and here when I'm doing hello world obj is basically the address of this, and then I am setting it. Then I am setting the value on the existing contract that is deployed, right? So these are the two ways of creating a new contract, right? One is basically creating a new contract, getting a new address. Another is using the existing address and then using those methods, right? On on the generated object or the object returned. Right. So these are the way where you can handle a new contract or the existing contract. Your contract supports inheritance, right? Inheritance basically those who are coming from object-oriented programming background, right? So you can say shape, SHAP, shape, right? So triangle is a shape, circle is a shape, right? So triangle, so shape is your parent class, right? Which has certain attributes or certain behavior, right? And triangle or a circle can inherit those attributes or those methods, right? So inheritance at high level is that. Single inheritance means a contract B is inheriting contract A, right? So assume that if you want to deploy your own cryptocurrency, right? So your contract, so there is already cryptocurrency defined, right? So there are standard ERC20 tokens. You just say contract new coin is ERC20, right? And everything that is defined under ERC20 will be available to this contract, right? So this gives you a simple example. You have a parent contract and you have a child contract, right? So in this case, child contract is inheriting your parent contract, right? So if you see, I am creating child contract object and I'm setting set integer, right? Here, if you see, child contract don't have a set integer, but as the inheritance goes, your father property will become your property. Similarly, your parent contract attributes and functions will become your functions, right? So if you see, even if I am deploying child contract, I am able to access set integer, right? So this is what is happening. What is simple inheritance? Multi-level inheritance. It may happens. You have a child, you have father, you have grandfather, right? So everything that belongs to grandfather and father belongs to child, right? And everything that grandfather has, father will own it. So these kind of multi-level hierarchy, right? Your contract B is A, contract C is B, right? So simple syntax. There can be possible hierarchical inheritance, right? Contract B also inherit A, contract C also inherit A. So multiple contract can inherit the same contract, right? So this is normal. This is troublesome anytime any language try to implement a multiple inheritance. It needs to be sure of few things, right? So here contract A, contract B, and contract C, and contract D, right? So in this case, contract D inherit from A, B, and C, right? So this is multiple inheritance, right? And it's problematic, right? Why I'm saying problematic? Take it as a homework and see why other inheritance is not problematic, but when it comes to multiple inheritance, it is problematic, and how Ethereum or Solidity is trying to solve it. Then we have contract polymorphism, right? Say if I have the same method, what will happen, right? So I have a parent contract which has get integer and set integer, right? And then I have a child contract that inherit the parent contract, and it has its own implementation of get integer. Okay, so if parent is called, it will return 10. If child is called, it will return the value of simple integer, right? So in this case, if I see what will be the answer here, right? So let's go slow. Here I am using the reference of parent contract, right? So parent contract reference knows about get and set signature, right? Here I am initializing a child contract. So what is happening here is the instance is deployed, right? So child contract is deployed, which is inheriting the parent contract. So far, so good. Now here, when I say inheritance will be called, I am saying PC parent contract dot set integer equal to 100, right? So let's what happening. So parent contract dot set integer, right? So simple integer will be 100, right? And then I say PC dot get integer, right? So PC is basically get integer, right? But your object is your child contract, right? So child contract will return simple integer value that is 100, not 10, right? So this is a very this is a polymorphism principle. Those who are coming from ops background will be aware about it, right? And I try to put it to be a simple example that based on the object or the contract that you deploy, right? Accordingly, its method will be called. Okay. Then there is a concept of abstract and interface. Abstract means that some of your methods are defined and some of your methods are not defined, right? So if you see any contract with some method only declared, right? There is no body. In this case, add a number has a body return tens, but get value and set value don't have a body, right? So it means it is abstract. So anything that is abstract cannot be instantiated, right? So you can inherit this, but you cannot deploy this, right? So new will not work on this. There is one more keyword called interfaces. Interfaces again more abstract than abstract contract itself. In this, none of the method will have implementation, right? And it will have a interface keyword. Again, interface cannot be initialized or deployed, so it can only be inherited, right? So that's about abstract and interface. Okay. Okay, so now certain few things, right, that will be important from code perspective, right? So let me. So I talk about very briefly. I talk about modifiers, right? Modifiers are the special code. If you attach to a function, it will change the behavior of the method, right? So this is what we will see there, right? So if I read it, modifiers are the special function that change the behavior of the function. This is what we discussed, right? Here the function code remains same, but the execution path of the changes, right? What it means is your function remain the same, but if you put a modifier on that function, modifier will be executed first, right? Let's now see how to write a modifier, right? So in this case, you have a contract without modifier, and you have a construct called modifier, right? So you are checking whether the callee is owner or not, right? So here I will check is owner, and I will check that message is a magic variable, right? If you remember from our discussion, dot sender, the person who is sending is the owner of the contract or not, right? So I have created a notation called is owner that will check whether owner is sending it or not, right? Now I can use this modifier, this annotation anywhere in my method. So I want to ensure that this function can only be called by is owner, right? So I will put is owner modifier here, right? But for say assign a tenor value, I don't want to put such restriction, right? So no need for that modifier. So modifier is the extra code that changes the execution of your method, right? So that's about modifier. Then you have view and pure functions. Again, right? So if you see the function, sometimes it will be return view and sometimes it will be return pure, right? What is the difference? Very simple difference. View means that you are reading the state, right? Here what is value is get tenor value. Here it means is you are basically you can read it from the state, right? What is state? State is something that is shared among each node on the database, right? So if you try to read something from the state that is visible to everyone, then you will use view, right? Pure means certain function, right? Where you don't read anything from the storage, but you just do certain processing, right? So for those you say use pure here, right? Here what is happening is you are consuming an argument and just returning it by multiplying 10, right? In this complete scenario, I have not basically read anything from the state, right? So given I have not anything from the state, so it's a pure function, right? So it is not even view function, where I am viewing a state. It's so pure that neither it modifies a state or it reads the state, right? So that's the difference between those two. Address, I told, right? Address is a type, right? So address has some inbuilt method. So anytime if you have handle on the address, you can check the balance, right? So if address belongs to a contract or address belongs to a person in a wallet, then of course they will have balance on Ether. So you balances that. Again, from that address, you can always send a certain amount, right? So you see that send, then you can transfer to different account, right? You can use transfer method. Then there are few other methods, right? So these are method, just check the signature of address and their inbuilt method, right? We will not go into deep into that, right? And you will use that, right? So basically, what we learn here is there are modifiers that can change the behavior of the method. Treat it like annotations, right? Then certain function only read from the state and certain function don't even read or write from the state, right? For that we have view and pure annotations. Address is a special type that has certain attributes and method, right? So balance, send, transfer, just go through the list from the net. Then the last piece of this. So there will be three words that you will see, right? The require, then you will see assert, and the last you will see revert. Okay, so so why we use it, right? So the require, when you see a require in the code, right, it takes a single argument, right? So it will check and it will take the conditions, right? So if you evaluate that condition, if it comes out to be true or false, based on that, certain things will happen, right? If the evaluation is false, assume that your data is not greater than equal to 0, right? It's negative value, then your code will raise an exception, right? And your execution will be halted. So at this point of time, your transaction that you are processing will stop here, right? And any amount of gas that is unused, it will be returned to the caller, right? So the person who has called, say with 100 gas, till this point 20 gas is used, but 80 gas is not used, then 80 gas will be returned to the caller, right? So this is what requires will do, right? And it will revert the state. So any state change that might have happened, it will revert those storage. Then you have assert, right? Here what will happen is it's same like the previous one, but with one difference. Here it will the unused gas is not returned to the caller, right? So even if it fails here, it will throw an error, right? Exception will be thrown, but it will not return the gas, right? So assume till here only 20% of the gas is used in this case, but 80% will not be returned to the caller. Again, in this case also state will be revert. Okay. And last, guys, there will be a revert statement. It is similar to require. The only difference is it will be not based on any evaluation, right? You just do a revert on your condition rather than revert evaluating it, right? So it's another way of writing require. So it's up to you. The most better way is use require, because in case if you want to return a fee, use assert. If you don't want to return a fee, right? Revert is another way, but it's only change in syntax where it just revert without evaluating any statement. Okay, event we discussed very say in a very brief way, right? I said these network don't emit any logging, right? So but you want to remain updated what is happening with the transaction or processing. So in this case, take this example. Here you have an event log function flow, right, which take a string, right? So I am saying someone is calling, say, valid integer. Then I want to acknowledge, right, by throwing an event that function within function validate, right? So it will go to the event. Then I say value is within range, it is validated, right? Returning the value from the function. So this is not how you will write the code, but it will give you an idea of how to generate an event, right? So first you declare the event. Once you declare the event, you can always call the event, right? And these event will be broadcasted, and any client that will be subscribing to it can listen to these kind of events. Right, so you can see, right, when logs are generated through the nodes, you will see that when you are calling it, right, these events are logs also. Logs basically stream to your client, right? So this is the last piece, guys. Um, so the main moot point is it's a very small language. In this say 60-70 minutes, I try to cover it, right, from the perspective that you are aware about the key construct. But again, if you spend next week going through the language in details, within 7 days, guys, I think you will be a medium level programmer in Solidity. That will not be possible with any other language, right? Maybe JavaScript, but you will not be proficient with any language within a week time. But Solidity, that is possible. So I'm open for any questions. Those who wants to ask question, they can unmute your mic. Those who are shy, they can put their question in a chat box. I will try to answer those questions. Also, this may be a more theoretical, more monologue. Reason being, mostly I have gone through the construct of the programming language, right? But next time we'll go through at least 3 problem statement. We will do the hands-on coding, right? So those who will be in front of a laptop or a desktop, we will take the problem statement and do the live coding there. So I can wait for 30 seconds. I will take up any questions, guys. No question, guys. Okay, so I will take. Okay, so please save the recording. Okay, so I think recording will be available on this chat. Okay, so no worries, guys. This may be a monologue session, but I don't know how to fit this into say a 60-minute thing. But next time we will do a hands-on. So phase is asking, are the arguments and functions executing also stored in memory, right? Or they are in call data, right? So they will be stored in call data, and you have to mention it, right? So if you check Solidity language, when you are defining your method, right, and its argument, you have to tell it, I want to store it either in the memory or the call data, right? So call data and memory are the two actual keyword, and if you prefix it with those keyword, that will define the destiny of your argument, right? So read about that also. So just see what is this keyword do when you append it to the arguments. Any other question, guys? Okay, okay, guys. Then So for next session, right? Two prerequisite. If you want to make that eventful, right? First, just theoretically go through the Solidity again, right? May not be this video, but go through some original source on the net, right? Try to go a level deep, right? Try to spend a couple of hours every alternative day or each day if possible. And next week, try to be in front of your laptop, right? And few tools already installed, right? So if not, even if you have browser, we can make it work. We have a Remix ID, right? So it's a web-based ID, and you can do many things on the on that